Good morning. Today we are moving on to CO56, continuing to work with those triangles. We are doing the Pythagorean theorem with triangles. Okay. So this is an important theorem that you need to know. You will see it again in the future. You will see it in other places. You might even see it on the math test next month. So we need to know the Pythagorean theorem. One of the oldest and most famous formulas in mathematics is the Pythagorean theorem. Its use is traced all the way back to 1900 BC, but is named after Pythagoras, a teacher and philosopher from around 500 BC. The Pythagorean theorem is used to find an unknown side length in a right triangle. So it has to be a right triangle, and we're going to find those unknown sides. So first, it's important to know the parts of a right triangle. So these parts all have names. So we have our right angle is right there, right? Where you see the little box, 90 degrees. That we know that's our right angle. The two sides that make up that right angle are called legs. So that is our A and B. A and B are the legs. They join to make a right angle. It doesn't matter which leg is A and which is B. C is the hypotenuse. It is directly across from the right angle. And it's the longest side of the triangle. So this is super important. You need to know A and B are the legs. So let me write it up here. So the legs are A and B, and they make the right angle. The hypotenuse is C, and it is directly across from the right angle. You need to know how to label that right triangle. Which two are the sides that make up the legs, that make up that right angle, and the hypotenuse C is directly across from that right angle. It's important to know which one is the C and which two are the A and B. So our Pythagorean theorem is A squared plus B squared equals C squared. We're going to see how that works. Okay? So this theorem, super important to know. A squared plus B squared equals C squared. So let's see how we use that theorem. All right, so I'm just going to write this again since I had to move it up. So we look at our first example. We know it's a right triangle because it's got that right angle right here. Which one should we call our A and which one should we call our B, our two legs? Joy. Okay, so that means which one is C, the hypotenuse? Jack?
5.
5, because it is directly across from that right angle. That is our C. So because this is an example, we know all three side lengths. We're going to see how this works. A squared, so that would be 3 squared, plus B squared, so that would be 4 squared, equals C squared, so that would be 5 squared. Let's see if that truly works. What is 3 squared? Nope, it is not 6. Because remember, we have to multiply. So what should it be, Moses? 3 squared. So 3 times 3. 9. Remember, for whatever reason, the 3 is the one that gives most people the hardest time when we are squaring it. Almost every time I ask what is 3 squared, I get a handful of kids that just think, oh, it's 6. Because in your head, you just add them together. Super common. Just remember, when we are squaring, we are multiplying. So make sure you're doing multiplication. What is 4 squared? Jackson? 16. What is 5 squared? Presley? 25. So now we're going to go back and see if these really do balance out. What is 9 plus 16? 25. So 25 equals 25. Let's do it with some different numbers. Let's look at our next triangle. What should I label the C, the hypotenuse? Which one would be C, the hypotenuse? Alex?
25.
How did you know 25 was the hypotenuse?
Because it's directly across from the right angle.
It's directly across from that right angle. That's how you can always know which one is the hypotenuse. Then we know our other two are the A and the B, the legs. The legs make up that right angle. So it doesn't matter which one I call A and which one I call B, because we're just adding them together. 2 plus 3 equals 5. 3 plus 2 equals 5. Doesn't matter which one we put first. We just know the two that make up that right angle are the A and the B. So let's put this into our formula. A squared is 24 squared plus B squared, so that's 7 squared, equals C squared, 25 squared. So, I love my perfect squares. They are my favorite kind of numbers, but I do not have them all memorized. So I do have to use my calculator for big numbers like 24 squared. So let's remind ourselves how we do that on our calculator. Some of us remember, some of us need a quick refresher. So let's look at our calculator. Trying to do this without a big glare. All right, so we see we have x squared right here. So I could do, what was our first one, 24 squared? So I could do 24 squared. So I can just use that x squared button. So 24 squared equals 576. So write that on your paper under a squared. That 24 squared, underneath it, write 576. Then, I believe it was 7 squared. So plus 7 squared is 49. And that equals, what is 25 squared? Leo?
625.
Yeah, because we could do 25 squared. So that equals that 625. So let's look back at our paper. We had, what was 24 squared? Somebody tell me what you wrote. Avery?
576.
576 plus 7 squared is 49. 25 squared was 625. So now we have to say, okay, does my left side actually equal my right side? Did I do my math correctly? Did I multiply or did I accidentally add them? So 576 plus 49. Who can use their calculator and tell me what that equals? Michael?
625.
Oops. Oh, yeah. I don't know what just happened there. So it does equal 625. So my two sides balance out. 625 equals 625. So does that make sense on why it all works? No matter what measurements we have, it will work itself out when it's a right angle. So let's look at our work for today. It says, use the Pythagorean theorem to solve for the hypotenuse of C. All three are right angles. So this one has our right angle marked, and this one has our right angle marked. Our middle one, it's not marked, but is it obvious to us which one would be the right angle? They didn't mark it, but they told us in the directions. So the directions are saying it's a right angle, so we can know that it's a right angle. We can see that this angle and this angle are obviously acute, so this one must be that right angle. So you can draw that box in only because the directions tell you it's a right angle. We can't ever assume, but if the problem tells you it's a right angle, then you know, yeah, it is, and we can mark it ourselves. So you're going to use that formula, a squared plus b squared equals c squared. So how am I going to write this out? Who thinks they know what our initial equation should look like? Michael?
The first one is 5 squared plus 12 squared equals what?
Equals c squared. Okay, so that a squared plus b squared equals c squared. We can fill in the a and the b. So 5 squared plus 12 squared equals c squared. It's important to note that that c is squared. So what is 5 squared? Joy? 25. What is 12 squared? Alex?
144.
And that equals c squared. So what's 25 plus 144? Ashley?
169.
169 equals, again, c squared. Do we want to know what c squared is, or do we want to know what c is? We need to break it down now to what c is. So thinking about those opposite operations, we are squaring here. We want to do the opposite. What is the opposite of squaring a number? Vinny? Close. Multiplying and dividing are opposites. What's the opposite? Think about PERMDAS. We've got parentheses. Then we have exponents and radicals. Exponents would be the squaring. What is the radical, Michael?
Trying to get the opposite of square.
Yeah, I'm looking for that word. What is the word that's the opposite of squaring? What is that radical called? I'm going to show you what it looks like. So if we have, I'm running out of room here, so I'm going to go down lower. We have 169 equals c squared. The opposite of squaring is this symbol. Does anybody remember what that symbol is called? Presley? The square root. So in order to get that c by itself, we have to get rid of that square. So we have to find its square root. And that's going to equal the square root of that number on the other side. So let's remind ourselves how we find that square root on our calculator. Oops. Okay, so we look at where that x squared button is. Look on the calculator on the part right down from it. You can see that little square root symbol. So to get to that, we do second, and then we press that button that's right below it, and now we can see that square root on the calculator. and then we put in the number that we want the square root of. Wonder what this. That helps get rid of some of that glare. Okay, so we can see right on top of x squared, we have that square root symbol. You can't see it well up on the camera here, but you do the second button and then that x squared, so you get that square root symbol showing up. Then you put the number you want the square root of, 169, and then that equals 13. So we go back to our problem. The square root of 169 is 13. So we're saying C equals 13. So now we can put that back into our equation and see if that works. What is 13 squared? If you type it into your calculator, 13 squared, what do you get? Jackson? 169. So if we say 5 squared plus 12 squared equals 13 squared, we get that 25 plus 144, and 13 squared is 169. 25 plus 144 is 169. It balances out. Both sides equal the same. So the really important thing that most people, when they get this problem wrong on the test, what they forget to do is to actually find that square root. The square root of 169 is 13. So many of us just say, oh, c squared equals 169, done. We don't want c squared, we want c. So you have to go that extra step and do the square root of both sides, so it goes down to just c equals this number. Okay. So this objective, the most complication comes into knowing how to use your calculator with those squares and the square roots. You're going to remember your formula, a squared plus b squared equals c squared. And then you need to remember to do that square root at the end so it gets down to just the c. You are going to do the other two on your own. And let's take a quick look at our word problem at the bottom. A rope is fastened to a tree 8 feet from the ground and then to a stake that is 6 feet away from the tree. How long is the rope? So it says sketch a diagram so we can see what our triangle looks like. Okay. So let's say I have my tree. Now, a rope is fastened to the tree 8 feet above the ground. So we know that this is 8 feet up to where that rope is tied onto the tree. Then it says there is a stake that is 6 feet away from the tree, and that rope is staked down right at that 6 feet. When we draw our picture, can we see our triangle? Yeah. So our right angle is going to be right here. So that 8 feet and 6 feet, what do we call those in a right angle? Fernanda? The legs. And we know our legs are our A and our B. And directly across from that right angle is what? Fernanda? The hypotenuse. And the hypotenuse we call the C. So we know our two legs make up that right angle, and the hypotenuse is directly across from it. Now we can do the Pythagorean theorem to figure out what that C is. Does that make sense? On the test, you're going to have to be able to draw a diagram. So draw your picture and label it how it's supposed to be. Any questions on this? I am gonna point out that sometimes you're always given two sides. Sometimes you might be given the A and the C, and you need to figure out the B. So you fill in your numbers that you know, just like we do when we know the A and the B. So A squared plus B squared equals C squared. So 3 squared plus B squared equals 5 squared. So then I figure out my squares. 3 squared is 9, this is still B squared, and 5 squared is 25. Now I have to do that opposite operation, because I can't say 9 plus B squared. I want to find out that B squared on its own. So I have to do my opposite operation. 9 minus 9 zeroes out. So B squared equals 25 minus 9 is 16. Then I have to do my square root, because I don't want B squared, I want B. 16, the square root of 16 is 4. So just know that if you're given a leg and the hypotenuse, you're going to have to do an opposite operation. Instead of adding A squared plus B squared, you have to do an opposite operation over to the other side. Does that make sense? So it's not on our homework, but you might see it on the test. You might see it on the math test that we take in April. You need to know how to figure out if you're looking for the A or the B. Okay, just remember those opposite operations. When you are finished with this objective, Khan Academy is due on Thursday. Math packet is due on Friday. So let's use our time wisely. If you get that math packet done, instead of putting it in the blue tray, bring it to me so I can correct it right away and give it back to you so you can be working on it. This is also a time that you can get checked off on your stations of the cross. So if you have those memorized, come up to me so we can get you checked off on that station of the cross. If you are watching this at home, I hope you are well. I hope to see you soon. Have a wonderful day.